Okay, good morning. Welcome to the continuation of our lesson, which I, on the spur of the moment, decided to title Slip Sliding and Dividing. Yes, so we're slip sliding through our slide and divide of factoring our trinomials with a leading coefficient other than 1. Now, incidentally, you can also do this if you have a leading coefficient of 1, but it's going to be really boring because sliding a 1 and dividing by a 1 don't actually do anything. Just going to toss that out there. So this part of the lesson is really just about exposing you to a couple more examples so you can see how this looks and you can see some different variations on it before you have to do too many of them on your own. The second example we are going to, well, let me put the steps up here. Okay, so I put up there kind of an abbreviated version of the steps, assuming that you've watched the last lesson and you've familiarized yourself with them. So let's take a look at our first example, which is, I have to flip my page over. There we go. It is, hold on, 2. There we go. That's better. 2x squared minus 5x minus 12. So step number 1, slide A by multiplying. Now by that we mean we're going to take the 2 and we're going to slide it down to the end by multiplying 2 times 12. You do not have to do an arrow for it or anything, or write times 2. But there it is. So x squared minus 5x, and then that'll be minus 24. Step 2, factor as before. So what we've done there is we've gotten rid of that leading coefficient. That's not 1, and we've rewritten the problem as a different problem with a leading coefficient of 1 that we happen to know what to do with. So we'll factor this as before. And we need 2 numbers that multiply to 24 and add up to -5. So you might do some scratch work. I'm going to do my scratch work in a different color just to make sure that you guys are totally clear. 1 times 24, 2 times 12, 3 times 8, 4 times 6. And I can tell by looking at that the 3 and the 8 is the pair that will give me the 5. And I can get a -5 if I do a positive 3 and a -8. You can do a quick little check on that, like 3 times -8 is -24, and 3 minus 8 is -5. Step 3, please don't forget to divide. Several years ago, I had a student that says, oh gosh, what did he say? Like, you slide and divide. If you don't divide, you won't be satisfied with your answer because it'll be wrong. So slide and divide. If you don't divide, you won't be satisfied with your incorrect answer. So when we say divide, what we're referring to is we're going to undo this like multiplication by 2 by dividing by 2. We divide by whatever we slid by. Step 4 is you need to simplify the fractions. Now, a lot of times there won't be anything to simplify with the fraction, just letting you know. But we do have a little simplification here. If I do 8 divided by 2, I get 4. And then step 5, where it says slide back, what we mean is we take the denominator and we slide it back. So we get 2x plus 3 and then x minus 4. Now, incidentally, if you wanted to check your answers, okay, your check would go off to the side somewhere. Okay, you're not going to do don't run your check into the work of the problem. Okay, like this is the end when you get to the factors. If you wanted to check it, you would distribute or FOIL. So let's take a look at that. So I would do 2x times x is 2x squared. 2x times -4 is -8x. 3 times x is 3x. And 3 times -4 is -12. And -8x plus 3x is -5x. And I dropped the square off there. And they match. So I have 2x squared minus 5. I paused it by accident. 2x squared minus 5x minus 12, 2x squared minus 5x minus 12. So I know that I've gotten the correct factors by doing that. That's a little bit more typical of the level of problem that you'll see. Now I'm going to give you a very important note. I think. I'm going to give you a very important note. So here's our note. If there is a GCF, and I'll kind of circle the word if, because not all of them have a GCF. So please don't make up common factors where there aren't any common factors. You want to look to see if there's a common factor. If there is a common factor, you want to grab the greatest one. You must factor it out first, or you will accidentally cancel it out when you simplify the fractions. And it's probably the worst drawback of this method is that you can end up losing the common factor if there is one. So you want to train yourself to always look for a common factor first. That there might not be one, so please don't make up common factors, okay? Don't think that there always is a common factor. But if there is one, you need to factor it out first and then do slide and divide. So of course I would like to show you an example of that so that you can see exactly what I'm talking about. So our example is, what is our example? It's this. 8x squared minus 34x minus 30. So we're going to look at this. Now this comes into that, like, you got to combine everything together. So you want to learn one skill because you're going to layer the skills on. So I have an 8, a 34, and a 30. Now you don't have a common factor of x because the 30 doesn't have an x. And remember, all of them have to have it for it to be common. Just go back to that candy tax. If one person in your group didn't have a gummy bear, then you're not taxing gummy bears. So if this guy has 2 gummy bears, this guy has 1 gummy bear, there's no gummy bears down here, you're not taxing out a gummy bear. But they are all even numbers. We have an 8, a 34, and a 30. And even numbers all have a factor of 2. So I am going to take out, we have a common factor of 2. Now notice I didn't say greatest common factor because sometimes you might not see the greatest common factor. You might get a common factor. And so you just you might factor them out in stages if you have to. So I'm going to take the 2. And I'm going to factor it out. Now, this is where division comes in handy. I could phrase this a couple different ways. I could say I have an 8, I factor out a 2, what am I left with? Or you could say 8 divided by 2 will leave you with a 4. 34 divided by 2 leaves me with a 17. And 30 divided by 2 leaves me with a 15. Because both division and factoring undo multiplication. So what we're doing here is we're actually using division to get the factors. Now I want to check and make sure that there's no other common factors because sometimes you're not sure if you got the biggest one. So before I move forward, I'm just going to check again. Like, okay, I have a 4. 17 is a prime number. And so that's a pretty good sign that there's no common factors left. 4 only has factors of 2. 15 doesn't have any factors of 2, so we're good. So now that I've got the common factor, now I can kick in slide and divide. So we're going to slide a down by multiplying a times 15. And you're just kind of leave the 2 here. I've got the 2 in a different color. It's going to hang out on the side there while we're busy doing slide and divide. So 2 comes down. Again, he's just hanging out. I don't know why the 2 is a guy, but the 2 is a guy and he's just hanging out. When we multiply, we'll get x squared minus 17x. Now, this you can do in your head. Think about time. If you have 15 minutes on the clock, if you have 4 15 minutes go by, how many minutes is that? That is 60. Sometimes you can do some math in your head if you think about some other things that connect with those numbers. Oh, whoops. Okay. Now I need to find, this is getting a little bit big, 2 numbers that multiply to 60 but add up to 17. So I'm going to start listing them. I have 1 times 60. Well, if I add them, I get 61. If I subtract them, I get 59. So not that. 2 times 30 If I add them, I get 32. If I subtract them, I get 28. Closer to 17, but still not close. 3 times 20. If I add them, I get 23. If I subtract them, I get 17. So that looks promising. Let's just double check though. 4, that's actually the one that I got the 60 with. So 4 times 15. Can I get a 17 out of that? I can get 19 and 11. 5 times 12. I can get 17 that way as well. So we want to be a little bit careful there. And then we have 6 times 10. Is there anything else? 7, nope. And 8, nope. And 9, nope. And then by the time I get to 10, I've already got 10. So we've got 2 different ways that we can get a 17. We need to make sure we pick the right one. And the right one is going to be the 3 and the 20. And let's bring the 2 down. I don't want to forget about the 2. So I can get negative 17 if I use a positive 3 and a negative 20. Now the way I know that is to get negative 17 with the 5 and the 12, they would both have to be negative, and a negative times a negative would give me a positive 60. So that's how I know it's not the 5 and the 12 and I have to go with the 3 and the 20, but you want to be thorough with that. Now we are going to divide. You got to divide. If you don't divide, you won't be satisfied with your answer. So we're going, don't copy that. We're just going to divide. Divide by 4 because 4 is the number that we slided. We slip slided the 4 down. So 4 is what we're going to divide by. And then you can probably do this in one step. So we're going to simplify the fraction and we're going to slide back. The 3/4 does not simplify. So I'm just going to go right ahead and slide that back and we'll get 4x plus 3. So I'm just going to kick that back. The 20 over 4 does simplify, but it's going to simplify in a way that I don't need to slide it. And there's my factors. There are actually 3 factors here. Okay, so we've got 3 factors. And they are a 2, a 4x plus 3, and the x minus 5. And it's kind of weird to think of those as being factors, but I do want to keep saying that. Factors are things that are multiplied together, and there's our multiplication. The fact that some of those factors are kind of ugly, that bears no mind. Okay, for this last example, we're going to take it up a notch a couple of ways. One, I'm not going to duplicate the steps. So at this point, you look at the steps, you refer back to the steps, but the goal is that you're going to move away from the steps because the steps aren't going to be on your test. So by the time you get to the test, you need to know what these steps are without thinking too hard about them. This one is going to be 15x to the third minus 4x squared minus 3x. Okay. Now you might think, hold up, Miss Taylor, that's not a quadratic because a quadratic has an x squared and nothing greater. And you would be correct. This is not a quadratic. Okay. This is called a cubic because you have an x to the third. So you can think about that. Cubic to the third, you cube something. This is a cubic polynomial, and I'm tossing it out there, not because I'm trying to throw you a curveball, but because I want you to see that math is consistent. And the rules don't change. The processes for doing things don't change, and you actually have all the knowledge and skills that you need in order to be able to factor this without me having to explain anything. It's just a matter of pulling the right information and applying it in the right way. And I like to show you that because teachers, we're not going to teach you every possible thing that you might see. And you might sit down to take the PERT. You might be taking the SAT. You might be taking an AP exam. I don't know what you're taking. Like the ASVAB, you're going to go into the military and you're going to see something that you haven't been taught. But just because you haven't been taught it doesn't mean you can't figure it out. A lot of times you can figure it out. And so to do this one, we're going to start with factoring out a GCF. And we've done that before. You know how to factor out something with the greatest common factor. So we're going to look at 5x to the third, 4x squared, and 3x, and ask ourselves, what do they all have in common? Well, in this case, they actually all do have an x. Not like this one, okay? This one, they did not all have an x, so you can't factor an x out. But this one, they do. So make sure you know the difference. We are going to take out a common factor of x, which you already know how to do. This is the candy tax. So we're going to take an x out, and we're going to be left with 15. Now, remember, if you have 3 x's and you take 1 out, you're going to be left with 2. If you have 2 x's and you take 1 out, you are left with 1. And here you have an x and you're taxing it out. There it goes. And now, once you've done the first step, which you knew how to do because you knew how to factor out a GCF, now you have a quadratic, and now it kicks back to something else that you know. So even though you didn't necessarily know 15x to the third because I hadn't showed you that, you did know how to factor out a GCF, and you do know how to factor a quadratic. And so if you can pull the right pieces of information, you can figure out stuff that you don't know, because math is consistent and the rules don't change. They're not random. So what worked for like 3 days ago is still going to work today. Now, slide and divide. You take the leading coefficient and you slide it down by multiplying. So we are multiplying by 15. Don't forget your x. He is along for the ride to the bitter end. 3 times 15, think about the clock. You have 15 minutes. 3 of them go by. That's 45 minutes. It's almost 1 class period. Now you have something that you factored before, something with a leading coefficient of 1. So we'll set up our parentheses, and you got to train yourself to ask this question. What are 2 numbers that multiply to 45 and add up to -4? So we start with 1 times 45. That's not going to do it. It's not even, so we don't have a 2. We can do a 3. 3 times 15. Now, here's something that's true about when you're doing these factors. If it wasn't divisible by 2, it's not going to be divisible by 4 either. Okay, it has to do with the fact that 2 is a factor of 4. So if you can, and there's that factor in dividing thing happening again. So if you can't divide by 2, you don't have to look at any other even numbers. Now, it does divide by 5, and we know that because it ends in 5, and that would be 5 times 9, and you might look at that and say, there it is. If I do 9 minus 5, I can get the 4. That's the combination we need. Let's just run through the rest of our factors. It's not going to be divisible by 6 because, again, it's not divisible by 2. Okay, so you don't have to figure it out. If it's divisible by 2 and 3, both 2 and 3, then it will be divisible by 6 because 2 times 3 is 6. Like, there's ways to get good at this. Then we can try 7. It's not divisible by 7. It's not going to be divisible by 8. And then when I get to 9, 9's already on the list. So that makes it pretty clear what we're going to use. To get -4, I will use a +5 and a -9. So in the parentheses, we have +5 and -9. Now, I forgot my x. Put that in there. Now, the next step is to undo the multiplying. And I undo multiplying with dividing. So I'm going to divide both by 15. Now we have to simplify it. So we have to, and remember, this x is along for the ride. Okay, he already played his role. You can grab your calculator to do this. 5 over 15 is 1/3. And then 9 over 15 is, what is 9 over 15? 3/5. And then the last step, we already undid the multiplying. Now we need to undo the sliding. So we've got to kick these back. The 3 is going to go in front of that x, and the 5 goes in front of that x. And so we have x, 3x plus 1, and 5x minus 3. And that is just another great example of just things that, like, if you put together the right piece of information, you can figure it out. And if you can do stuff like that on your own, you're going to feel so good about yourself. You might feel like like, oh my gosh, I'm like super smart at math, and you are. You know, you can like kind of pull this together. What my point is that I don't want you quitting just because something looks unfamiliar. Like, think about what you do know, what you can show. So nothing is left except for you guys to get some practice. So let's put some practice problems up here. So here they are in all their glory. You do not have to do them in any particular order. So if you're looking through them and there's something with some smaller numbers that looks like it's easier, feel free to start with the ones that you think are easier. Do be careful about the common factors, okay? So look for a GCF first. Because like you start seeing something like 21 and 18, you think like, oh, those are kind of big numbers, Miss Taylor. Yes, they are. So check and see 21, 18, and 3 do have a common factor. So we're going to stop the video here, and I will post the answers on the next slide just for anybody who's getting practice at home. And here are the answers. So I'll hold here for a second, or you guys can pause it if you're watching at home. And just see how close you came. Remember, if you have the right like stuff in the parentheses, but you've got like the signs, like the pluses and minuses mixed up, that's like something that you can catch when you're doing your checks to it. And like you just need to do the check. You need to straighten out a couple things about the pluses and minuses. But I mean, it's a fairly simple problem to fix. You just need to take the time to do it. And now you know everything at this point that you need to know about factoring. There's actually only a couple of additional things that I even can show you about factoring, and that's going to come in a future unit. So all that remains is to just really practice with this.